Hi, I'm Poojan Shah and I'm gonna talk about my EC484 final project and I'm gonna work on a GRAIC. My title of my project is How Fast Can You Go? The agenda for today or for doing the speech presentation is give intro, discuss about problem statement, my approach to that problem statement, plan and preliminary work that has been done, milestones and evaluation metrics. Problem statement for the GRAIC is defined. It is to finish a racetrack as fast as possible, and I identify three key things. One is collision avoidance, lane following, and waypoint tracking. And ideally, in order to solve this problem, you might require trajectory planning and control module. The approach to solve this problem, as I discussed, is develop a trajectory planning module and the control module. So based on the ground truth information, I have generalized waypoints, lane information, and obstacle information. Now from that, if I can generate a localized waypoints, fit the curve, and then create a trajectory states on it, that will give me my trajectory planning model. Now based on the trajectory states, can I do a different control strategy to satisfy my trajectory? And this what I want to experiment with is different control algorithms, which includes PID control, pure pursuit, Stanley, LQR, MPC, and constraint based MPC. Now this is the flow or pipeline will look like. So I have a ground truth information. So this will act as my ideal perception module, which is lane information, obstacles, and waypoints. Now what will planning module do is it will generate a local trajectory, and instead of doing an interpolation between the local waypoints, how I'm doing is I'm using spline or Bezier curve, and based on those planning module I will get a trajectory state. Now this trajectory state consists of information about longitudinal, lateral, speeds, accelerations, and in order to follow that I need to develop a control algorithm, which is adaptive PID, pure pursuit, LQR, MPC, or Stanley controller. The output will be longitudinal speed and the steering. Apart from finishing racetrack as fast as possible, I also want to do comparison study for different control strategy and how better they are. For preliminary work, I have already set up a simulator. My pipeline is working. I have my personal machine which is Ubuntu 22, and I have to use Python 3.7 because that was a requirement, and also I have to update to Kala 0.9.15 instead of 0.9.13. Milestone. So first milestone is already achieved. Second milestone is lateral control with PID. So if I have a local waypoint information, I want to do the experiment with simple PID to see whether my vehicle is able to follow how well it can be controlled. After that, I want to develop a whole trajectory module for lateral control. Then that will help me to implement Stanley and pure pursuit. Then I want to go include the longitudinal information, and then I can try with advanced control strategy of LQR or MPC. How I want to test this is based on desired speed, because we are seeing how fast I can go. Then the desired different control parameters, which includes control gains, look ahead distance, different cost metrics or weight metrics. Then I also want to perform a dynamical modeling versus kinematical modeling study, and of course I'm going to test on different tracks. The key performance indicator, all the metrics for this is, first you do different tracks without any scenario, and then you do tracks with scenario. Now for this, both of them have a similar evaluation criteria, which is a score or time to finish. Jan's naive controller is able to do it with certain time. I want to do it at least faster than that. So for initial target, I'm doing 10% more faster than that. Then number of collision has to be 0. And since I'm doing controller performance study, I want to compare different controller against different parameters, which includes speed, lateral acceleration, longitudinal jerks, longitudinal acceleration as well. And my target is plus or minus 6 meter per second square, as for comfortable driving it is plus or minus 4 meter per second square, especially for lateral acceleration. And the references are different control strategies has been done on the hardware. So I want to see, and that means that it can be doable on simulator. And thank you. Let me know if you have any more questions on this.